All right, so today we are going to jump into section 2.2, composition of functions. In section 2.1, we dealt with the different ways of combining functions through addition, subtraction, multiplication, and division. And now in section 2.2, you'll be introduced to the composition of two functions. So let us dive into looking at these two functions given to you. F of x equals x squared. We all know that this is the parent function of a quadratic. Okay, and a quadratic are those functions that look like parabolas. And the other function given right here, this is a linear function. Now I'm just going over this because it's just functions that you should be able to recognize. Anyhow, we're going to compose f with g. Now you do not know exactly what that means, so we're going to take it slow and work up to exactly what composition involves. So given that f of x is x squared and g of x is x plus 1, let us take, for instance, the question if I asked you to evaluate f of 3. Okay, so this is function notation saying I need you to find the y value when x, okay, is equal to 3. So you notice that f is defined as x squared, so we can use that information to help us find f of 3. So we substitute 3 into x, and 3 squared is 9. So f of 3 is 9. So this is a mere substitution problem. Okay, we took the value that was given to us, substituted it, and simplified based on what the function was. But the problem is, or not problem, the issue that you are going to start seeing is that you will not always substitute defined x values, okay? So x is given, okay, and in here it has been defined. But what if what you're substituting is no longer defined? What if now we will start considering substituting functions into functions? So all along, let's write this down. All along, you've substituted given domain values, okay, given x's. Okay. Now let's move on. Now let's move on to substituting functions into other functions. And this, in a nutshell, is what composition is all about. So, let us look at what the definition says as far as the notation of function. And the first thing we're going to do after that is look how to compose functions visually. So let's look here at this notation. So f composition g of x can be rewritten as f of g of x, okay? Now, with this notation, I always want you to recognize that you will always need to start with the function that is inside the set of outside parentheses. So I need you to always start with the given function and work your way out, okay? So over here, I'm going to put a reminder. Start from the inside and work your way out. Work your way outwards. Okay? So, let us look to exactly what is Hanlon talking about when she says that. I think the best way to introduce composition, if this is your first time, is looking at visual representations. Okay, so here, let's examine, I'm going to write this down here. Let's examine visual composition. And the visual composition can come in the form of tables or of graphs. Okay, so let's look at a table first. So in this table, you're given 3 rows. The first row is the x value row. The second row is the f of x function row, and the g of x row is the last. What does this mean? Okay, I don't want you to just see this as a table of numbers. You need to understand the significance between these numbers, okay? So basically what's happening is that I don't know what my f and g function is. If you notice here at the beginning of our notes, they told us what f and g was. They told us f was x squared. They told us the g was x plus 1. In the table, they do not give us that definition. They just told us, hey, we already did the work for you. Here's the answer. So they're telling us, hey, when you plug x into the f of x function, this is the answer you're going to get. When you take this x value, -3, and you plug it into the g of x function, this is going to be your answer. And you repeat that, and this is how they compile to this table. Now, we're going to use this table to sort out these problems and work them out. So I'm going to use this white space here on the right because it's more space. And let's start out with A. So let us rewrite f composition g of 1. I'm going to rewrite it using it the way I learned up here in the table, okay? So f composition g, notice you just write your f, open your set of parentheses, and the g and the x, put it inside and close parentheses. So I'm going to do the same thing with this one. F of g of 1. So first step, rewrite. Write it in function notation. Now, what did I say? I told you guys to always start from the inside and work your way out. So the innermost part of this function notation is this. So what I need you guys to recognize is that that value is your x. That's your x value. It's a defined value, okay? So they're telling us, hey, start at the x value. So I'm going to go to the x value 1 on my chart, and I am standing here currently. Now, what are they telling me to do with that 1? G of 1, remember I told you it's important to understand what that notation means, okay? G of 1 says, go find the y value when x is 1. That's what G of 1 means. So I'm standing here when x is 1, and I need to go find that y value. Well, I'm going to drop my eyes down to G of 1, because that's my answer. That's the y value when G is 1. So my answer is a 0. So G of 1 is a 0. But I did have this f on the outside. So I found out that G of 1 is 0, but I can't just forget about this variable here. So I need to bring it over because I am going to take the f of the answer that I just got. So now this 0, which was a y variable, right? Because 0 is right here under your y variable, which is g of x, your output. But now notice that this 0 becomes my new x value. How do I know it's my new x value? Well, isn't this f of x? And 0 is standing in front of the x. This is my x value. This is the domain. Anything inside of the parentheses is always your domain value. So I start over. I go back to my chart. I go to 0. I'm standing here, and I'm telling myself, oh, well, 0, go find the y value at f. So at 0, I need to go to f, and the answer is 5. Let's do it one more time, and then the rest you'll do it yourself. B, f composition g of 2. So I'm going to write it as f of g of 2. let's start over. Let me erase my little markings here. We will start at 2. 2 is my x value, which was given to me. So I'm going to start at 2. I'm standing right here waiting for my next command. The command is go find the y value in your g function. So I'm going to bring over my f, and I'm going to put the answer to what I found g of 2 to be, which in this case is -3. That's my g of 2. So -3. Now this is my new x value. I'm going to put it in yellow just to differentiate. So this is my new x value. And they're telling me go stand at -3 and go find the y value for f. So where's my -3 right here? Where's my y value for f? Go to the f row, and it's 11. So what I want you to do right now is pause the recording and go finish C, D, E, and F and check your answers by unpausing the video, okay? Okay, so at this time, look at the answers. And if you need to pause the video again, pause it so that you can check all your work. All right. So at this point now you would have checked your work. Let's go on to another visual example. Instead of table form, we're going to look at graphing form. So let me shift this down a little bit more, and let's go to graphing. So in the graphing form, we are going to start out with the same approach. Rewrite your composition notation into function notation. So, oops, I need some more lead. Stand by. Okay. So h of f of 3. Please realize that even though our visual has changed, the approach to this problem does not change. You are still going to start with your innermost value, which in this case it's defined as a 3. And I'm going to go from 3 and substitute it to find my f function value, my y value. This is still an x, okay? Still, you are still being given an x value. Where is my x value in this chart? Well, x values are all found on the x-axis, okay? So let's label this as an x to remind us. Now, there are 3 functions that are being graphed in this one grid. You have the h of x graph right here. You have the g of x graph and the f of x graph. So you have 3 different graphs that you will be referring to. So pay attention to which one they're talking about. So we're starting at our pink 3. So go to the x-axis, put your pencil at the 3. Okay? Over here we would always start on the x as well, and we just circled where we are. I'm going to put my pencil at 3. Now what do? Well, the 3 needs a y value on the f function. So I need to figure out which one of these is my f function. Well, I noticed that my f function is the purple one, which, well, they're all purple. The f of x one, which is this absolute value function right here. So if my pencil is where it's located and I'm asking you to find the y value, remember y value is how far up or down you're going, okay? So if I'm standing here at 3 and I need to go to this function, I am going to go 1, 2, 3, 4 units down to be able to touch my f of x function. So what is f of 3? I went down 4. So I bring the h and I put -4 because I went down 4. And then I repeat. So I'm going to erase these marks. I start over because guess what? Just like upstairs, this is now my new x. So you see, up here, let me shift this up to make my point. See? You started out with this x. It gave you a y value answer. The y value became your new x. Again, you started out with the x equals 3. To find my y value of down 4 changed to become the new x. I go back to the x-axis because that's a -4. 1, 2, 3, 4. I'll put my pencil right there, and then I need to see where do I need to go to get to h. Well, do I go up or down to go to my h function? Well, if my h function is this function up here, that means my pencil needs to go up. Let's count 1, 2, 3, 4, 5 units, then it finally touches the h of x function. So I had to go up 5 units. So now what I want you to do, pause, work out the next 4 problems, and then unpause and check your work. Go so now. Okay, so at this point you are checking your answers. Again, you can pause the video so that you can check it, and then we're going to proceed into the last section. All right, so at the back side of your note-taking guide you have some space where you can continue doing your guided notes, and we're going to work out classwork problems specifically that will help you in completing your Delta Math assignment, section 2.2. So let's start off with the first of 4 examples that you will need to complete with me before I let you go. So first example, I'm really running out of lead here. Okay, f of x equals x squared plus x minus 2, semicolon, because I have another function I'm going to give you, and it's the g of x, negative 4x minus 6. I want you, in this problem, to evaluate the composition f of g at negative 3. Okay? So let's rewrite just like we've been doing all along. So we've done the visual composition. We're going to do algebraic composition now. So rewriting this, I get f of g of negative 3. Okay? What do I always tell you guys to do? Start from the innermost value. Innermost value is right here. In this case, it's a negative 3. I am going to take my negative 3 and substitute it into my g. So they're asking me to find g of negative 3. So let's do that. G of x is given to us, so g of negative 3 merely means take the negative 3 and put it in for every x that exists in that function, which in this case there was only one x, so it was pretty straightforward. What is negative 4 times negative 3? It is positive 12. Bring down the minus 6. And 12 minus 6 is 6. So our g negative 3 is 6. So what does that say we can do? Well, if I know this is equal to this entire thing can be replaced with the number 6. So let's do that. F of g of negative 3, which we found to be 6. And what does that function notation mean? It says when x is 6, what is my y value in the f function? So I need to go look at my f of x function, substitute every x with 6. So 6 to the second power plus 6 minus 2. Order of operations says that we do exponents first. 36 plus 6 minus 2. And then I combine like terms from left to right. 36 plus 6 is 42. 42 minus 2 is a 40. So f of g of negative 3 is equal to 40. Now, when it comes to Delta Math, you are only going to type 40 for your answer. You do not need to write out the entire script. But here's what I'm going to ask you guys to do. I want you to take notes when you guys are doing Delta Math. Take out a note sheet of paper, write out the problems, write them out neatly, and make sure you understand what's going on, and use that as extra notes to what I'm giving you today. So that way you have that extra note paper with reference materials in your text, not your text, but in your binder, okay? Okay, let's go to number 2. So in number 1, I want you to notice that x, I write too hard, I guess. The x value is defined, okay? So notice example number 1, and in your Delta Math, you have a couple of these. The x value has been defined. We know what it is, so it's glorified substitution, okay? We substituted into one equation, got an answer, got that answer, substituted again, and it's a chain reaction. Oh, excuse me, guys. Now, what happens when I don't give you a defined value? So let's go ahead and practice doing that, okay? Oh, let's change up the letters. We're getting tired of F and G. Let's try H and G or something. Let's call this h of x equals negative x plus 6. Oh, let's do m of x, m for math. M of x equals 2x squared plus x plus 2. All right. This question is going to have 2 parts, all right? So the first part, I need you to evaluate what do I want you to do? M of h of x, which just means what? If I write the composition form, what does that mean? I am so sorry. I am yawning in the middle of my video. Okay, it's 8th period, so I'm really tired. But here we go. So, here's the question though. Ms. Hanlon, how can we do this? Because x is not being given to us, so I don't have anything to substitute. So that's what I was talking about over here. All along you've been substituted giving a specific domain value, a specific defined domain value. But now you're going to substitute functions into other functions, okay? So here they didn't give us an x. They didn't. They said take the x and substitute it into h. Well, we already have h of x, okay? So let me highlight this to make it visibly clear. This is my h of x. It was already given to me. It's right here. Okay? So what I need to do is I need to take this h of x and I need to take it and replace every x of my m. Now notice that my m has 2 x's. So that means this pink value here has to go over to the m and needs to dump itself into this x as well as this x. Okay, that's what composition means. So I'm going to write the word substitute here so you understand the direction we're going in. Okay, the h is going into the m. The h is going into the m. So let's rewrite that. Let's put equals to. So take this pink and put them in there. So let's write 2, open parentheses because there's an x, and replace it with negative x plus 6. Bring this 2, bring down the plus. There's another x. I need to substitute it with negative x plus 6. And then bring down the plus 2. So literally you are ignoring completely. I'm highlighting here with a pencil highlight. You're getting rid of the x. If you had a substitute teacher, that means you got rid of Hanlon. Hanlon's no longer in the classroom. The substitute replaced her. So think of me as the x, and I've gone on a little sweet vacation for a couple of days. The substitute, which is my pink value, is coming over and it's going to do everything that I do. So they take care of stuff in my place. Once you get to here, all this is just an Algebra 1 problem. Okay? This is all about simplification. All right, so what do we do to simplify first? Well, exponents. Exponents need to be done first. Don't start distributing. You've got to take care of your exponents. So here's the thing. This is my exponents right here. I'm having negative x plus 6 raised to the second power. What a lot of students do, and it's a big no-no, is they take this exponent and they distribute it to each term. That is absolutely incorrect. Okay, that does not work over addition. Your distribution of an exponent can only happen when everything inside the parentheses is multiplying. So what do we do with negative x plus 6 to the second power? So I'm going to come over here and create what's called some side work. And let's do negative x plus 6 times negative x plus 6. That's what squared means. Take the term and multiply it by itself. So what does that look like? Well, it looks like it's a distribution problem. Negative x times negative x. Negative x times 6. 6 times negative x. 6 times 6. And we notice these are like terms, so we combine like that. Now I need to make my way back to my original problem over here because I was just working this out. I still have everything else I need to do. So I'm going to bring down my 2, but instead of writing negative x plus 6 all squared, I'm going to write down the final answer of negative x plus 6 all squared. So x squared minus 12x plus 36. And then there's an invisible 1 that's being distributed, so that just stayed the same. Now, distribute. Bring down all your terms. Okay. Notice you're just doing basic, simple algebra 1. And then we combine our like terms. So let's highlight the x values, right? And let's highlight the constants. Okay, they all belong to the same family. And our final answer is 2x squared minus 25x. Let's see, 6 and 2 is 8, and 70, no. What? Oh, sorry. 72 plus 6 is 78, and 78 plus 2 is an 80. All right, that's 2 part A, okay? And now I want you to do 2 part B, whereby we go in the opposite direction, and I want to prove to you that composition is not commutative, okay? So let's evaluate h of m of x. Okay, so we rewrite that as h of f of x. So what's getting dumped into what? Well, again, our f of x is our innermost function. We start with the f of x and not x because x has not been defined, right? And we're going to take that entire expression and we're going to walk over. Oh, I can't do my walking over. Well, I can guess I'll point it up here. Why am I using m? I mean, why am I using h? This is an m. Goodness. Hold on. Hanlon, is gone back using the previous letters. These are not the letters we're doing. We did M composition H. I'm doing H composition M. So H composition M. Okay, hope I can make that darker. Ugh, that's just awful, isn't it? Okay. M. Okay, hopefully you can see that close enough. Oh, it's better on the screen than on my paper here. Okay, back to doing, instead of M composition H, we're doing H composition M. And I'm telling you that I want to do this because I want to show you that just because we got this answer, doing the composition in the direction we did, does not mean that in the other direction you get the same. Sometimes you do, but not often. So let us first do M of X. That's the first thing we need to do. So look at M of X, which is this. I gotta bring it down again. Oh, it's right here. Okay. So look at this M of X, which is this. And I need you to take that, walk over to the H function, and dump that M of X function into every X on his side, or her side. So let's do this. So if I'm taking this whole thing and dumping it over here, this X is disappearing. So I have a negative and I have a blank spot for my X, but I know that my X is M of X, which in this problem is 2x squared plus x minus 2. So I need to put it in parentheses. 2x squared plus x plus 2. And then I need to do, what am I doing? Negative, oh, okay. So that's negative x plus 6. So that's negative x. And then I need to put my plus 6. And now all you're doing is simplifying. Once you've done that substitution, it's mere simplifying Algebra 1 stuff. So the negative 1 needs to do its job of distributing. So we're going to get negative 2x squared minus x minus 2 plus 6. This is our like terms. So negative 2x squared plus minus x. Negative 2 plus 6 is a positive 4. Okay. And that's it, my dears. That is your lesson on section 2.2. Now head on over and complete Delta Math. It's labeled as homework 2.2. Thanks for listening and watching.